Welcome to 9.2 Logarithms and Logarithmic Functions. Today we're going to talk about these two items and how we can manipulate things and what these actually mean. So if you've never heard of a logarithm, that's totally fine. Hopefully by the end of this you'll have a basic understanding of what they are and how we can use them. So what is a logarithm? It's basically a relationship between the number and the power that a number is raised to. So defining it, okay, it's going to help if we use this. This is what a log actually looks like. This is how it's written right here. And how this is read is it's read as y is log base b of x. So this is what we call the base. And I do want you writing this. So it's y equals log base b of x. So the base is always down below. It's represented by b. And really, how we're going to use this helps us define what it is. So the two things that you can cycle back and forth from, and keep in mind that we do have these variables. So this first variable, b, if it's log base b of x, okay, base b means that base is still going to be there. Okay, it's still going to be the base, so it's going to be something raised to an exponent. And this y is going to be that exponent. So it's going to be b to the y, and that's going to equal x. So a quick way to remember this is to say b is the base, because remember when we talked about it, log base b of x, b is still the base. It's being raised to a power. It's not being raised to what's right next to it. It's being raised to the other part, and that equals x. So what we're going to do is we're going to be able to cycle between these two, and this is going to be huge. This slide is going to be one of your most important slides that you're going to have to use, because what it's going to allow us to do is toggle between these two different forms and manipulate functions and equations using it in order to solve. So a logarithm, it's a relationship between a number and the power raised to it to get to a certain number. Okay, so that kind of helps define it. So what we can do is we can take each function, or each log rather, and we can take it and move it to that form. And I actually included this right down here just for you. And if you want to color code things just to think about them, that also helps. And then so what we're going to do is we're going to take this and we're going to say 8 is the base. It's being raised to not what's right next to it, but the other part. It's going to be raised to the 0 equals 1, and that's true. 1 equals 1. Okay, so we're just worried about writing it in this exponential form. Here we have 2 as the base, so it's 2 to the negative 4 is equal to 1 over 16. And if you remember, 2 to the negative 4 could be written as 1 over 2 to the 4th. And it is, in fact, 1 over 16. Again, if it's asking you to write it in exponential form, though, we're just taking it and writing as the exponent. I just took it a step further to say, yes, it actually did work, and I did put it in the right order. So it's a good double check to do. Now, the other way we can do this is we can go the opposite way. So we can say, given this exponential, how can we rewrite it? So we automatically know that this is b. So I'm going to use log base b of x equals y. I'm going to use this portion, and now I'm just going to plug things in. So I know that it's log base b, so I know it's log base 10. Our x, if you look over here, was what it was set equal to. So this part is x, so it's of 1,000. And that equals our y, which was the exponent that was raised to. So y is 3. A good double check on this, because I think that this way is a little bit more difficult to go back and forth from. Okay, to start with this and write it as a log, I would quickly say 10 to the third equals 1,000. So 10 to the third equals 1,000. That's exactly what we started with, so we know that we've done this correctly. And that's what I do almost every single time. Okay, so identify this as y. It's equal to x, because we're in this form. This is your base, so you're going to have log base 9 of x, x was 3, and that equals 1/2. And again, 9 to the 1/2 equals 3, and that's exactly what we started with, so we know that we've done the correct thing. If we're asked to evaluate logarithmic expressions, okay, so we're evaluating this piece right here. This is another type of problem that you'll have. What you'll want to do is you'll say, this piece is equal to something, and I'm just going to say it equal to y. So we're trying to figure out what it's equal to. We're trying to figure out what this y value is, but we're going to use logs to do so. So using that property of logs from the previous couple of slides, we can say this is 2 to the y is equal to 64. And now we can solve it just like we did in section 1. So we can write 64 as 2 to the 6th. And now that our bases are the same, we can say y is equal to 6. And we can quickly plug that back in to make sure that it does in fact work. So our steps, we set it equal to y. We use that logarithmic property and say 2 to the y equals 64, and then we get like bases and solve. Let's do another one. Log base 3 of 81. We're trying to figure out what that equals, so we're just going to say it equals y. So 3 to the y is equal to 81. If you rewrite 81, it is 3 to the, let's figure it out. It's 3 squared, so it's 3 to the 4th. So now that our bases are alike, we have y equals 4. And again, we can plug that in, make sure it's right. If we have a logarithmic equation, okay, notice we don't have to add an equals sign here. It's already here. But what we can do is we can say this is like 4 to the 5/2. And again, this is just using that basic rule, and that equals n. So if we can figure out what 4 to the 5/2 is, that's going to be equal to n. So I'm going to take 4 to the 5/2 and I'm going to rewrite it as 4 to the 4/2 times 4 to the 1/2, because I would know that I would add these exponents and get 5/2. So now 4 to the 4/2 is like 4 squared, which is 16. 4 to the 1/2 is like square root of 4, which is 2. And now we have, that should be an n, my apologies. And now we have 32 is equal to n. So if there's already an equal sign there, use that property. If there's not one there, we want to evaluate, we want to try to figure out what it's equal to, so we have to set it equal to something, such as y. We're going to do the logarithmic inequalities in class, so don't worry about this slide. We're going to actually jump down to the next slide, which is key concepts. So what this is saying, if b is a positive number, okay, the base always has to be a positive number, and it's other than 1. So if you look at these, the only thing that is different here is the y's. It's log base b of the same thing. Then you'd say x is equal to y. And we're going to see this in the next example. So these two pieces would have to be equal in order for the entire piece to be equal. Here we check it out. So we have log base 5, log base 5. We know that these are the only two components of it. This piece is set equal to this piece. So what we're going to have to do is we're going to have to set what's inside equal to what's inside. Anytime we have a p squared, we want to move everything to one side by doing operations to both sides, get it to 0, and then we factor it. And when we factor it, we get p minus 2 and p plus 1. And then we go ahead and set each of these factors equal to 0, so we get p is equal to -1. And we get p is equal to 2, okay, in order for those to be 0. So if our bases match, we set each component equal to the other component. All right, I encourage you to watch more additional videos for additional help, and come see me if you need me.